My name is Dr. Mallikarjun, working in Institute of Aeronautical Engineering in the Department of Information Technology. In the series of video lectures, Operating System, today I am going to discuss about the arrival time AT, burst time BT, completion time CT, turnaround time TAT, waiting time WT, response time RT. We will know all these time values in this video lecture. See, arrival time, burst time, completion time, turnaround time, waiting time, response time. These all we are calculating in the process scheduling. Process scheduling is the very important issue in the operating system point of view. So the process allocated to the CPU, that process when it's completed, it totally depends upon the time factor. The how much of time the process can be depend and execute in CPU, the time, what time the process can complete from the exit from the CPU, that's totally depend on the process execution time. The execution time can be categorized arrival time, burst time, completion time, the different time factors. So we will know in this video each time factor. Okay, that is arrival time. This is a very important. The process once reached to the CPU, that is a execution. For the execution, that is called arrival time. In the context of operating system, arrival time refers to the time a process become ready for execution and enters the ready queue. It is the total moment of a process is available to the schedule for CPU time. This is different from the burst time. The time process need to execute and completion time when it execution finishes. That's all we will see from next slide. That is completion time, burst time. This arrival time is becomes ready for the execution. This is the point we should know and notice that is a very important point is, and I am underlining that becomes ready for the execution to enter the ready queue. That is a arrival time. Burst time means that amount of time the process needs to execute on the CPU. That amount of time means that that is the time the process needs to execute. Essentially, the CPU execution time required for a task. It is a crucial factor in CPU scheduling algorithm. The calculation of the burst time, the amount of time for executing the process in CPU, that is means burst time. It leads quicker process completion and better system resource utilization. That is depend upon the burst time. Means that the process need executing time in the CPU for that time is called burst time. Burst time. Next, completion time. In an operating system, completion time refers to the point in a time when process finishes its execution, meaning it has completed burst time and is no longer running. It is a crucial metric that when process is completed in CPU scheduling, indicating when a process is done, can be removed from the system from the active state, from that when the process completed that state. That is called completion time. So we will calculate all these things for the depend upon the problem. That is a turnaround time. Turnaround time refers to the total time it takes for a process to complete from initial submission to its final completion. Once the process initial to complete and it complete for the final completion, this includes both time spent executing on the CPU and time spent waiting in queue or input output operation. That's everything depends upon the turnaround time. It is a key metric for evaluating the efficiency of CPU scheduling algorithm is to calculate the turnaround time. We will discuss in detail about the turnaround time after this slide. That is now we will know about that waiting time. This is a total time process spent in ready queue waiting for its turn to be executed by the CPU. It is a time of the process in ready to run but it is not yet allocated to CPU. Essentially, it is the difference between when process arrive in the ready queue and when it is actually starts running. That depends upon the waiting time of the process. Response time of the operating system, the time it takes for a system, it is a react to user request or input. It is a crucial metric for evaluating the performance and user experience of an operating system. A faster response time indicates a more efficient and responsive to the system. That is depend upon the response time. Yes, there are scheduling algorithms are two types, preemptive scheduling and non-preemptive scheduling. Preemptive scheduling means the process can be switched to the next process in the executing. Means that its context switchings are more depend upon the time quantum and the time slice. It can preempt in the running the process to allocate CPU time to another process. It typically based on priority or time sharing policies. Mainly process switched the running state to the ready state. That preemptive scheduling algorithms are round robin and shortest remaining time first, and preemptive scheduling algorithms, these are comes under preemptive scheduling process. Non-preemptive means once process submit to CPU, it complete that entire execution. That is comes under non-preemptive. Means that the process CPU voluntarily relinquish it to control of the CPU to give the next process. Means that the process completed the entire execution, then it go to the next process for in the non-preemptive. The first come first serve, shortest job first, those all are comes under non-preemptive nature, non-preemptive scheduling nature. Okay, coming to turnaround time. This is a very important factor to find in the arrival time, bus time, completion time. So first you have to calculate the turnaround time. You have to calculate it previous arrival time, bust time, completion time. Then you have to calculate the turnaround time. That is important criterion is how long it takes the execute that process. The total amount time is spent by the process from its arrival to its completion. That is called turnaround time. Is the sum of time spent waiting to get into memory, waiting to ready queue, executing in CPU, and waiting for input output calculation. So the turnaround time TAT we have to calculate, that is completion time minus arrival time. We have to calculate the turnaround time. Completion time, the process enters into the completion state, or the time the process which the process completed its execution is called completion time. The arrival time, the time which the process enter into the ready queue is called the arrival time. Okay, so non-preemptive scheduling is completely different. The process terminates or process switches from the running time to waiting state. In this scheduling, once the resource of CPU cycles are allocated to a process, the process holds the CPU till gets terminated or reaches a waiting state. In this case, non-preemptive scheduling does not interrupt a process running CPU in the middle of the execution. Instead, it waits till the process completes its CPU burst time, and then it can allocate the CPU to another process. That's totally depend upon the non-preemptive. So the first come first serve scheduling is also a non-preemptive nature. It's that in that allocation of the process CPU to switch to another process after complete the entire process. So this is a non-preemptive nature. Okay, now we calculate arrival time, bus time, completion time, turnaround time, waiting time, response time for a simple example problem. Okay, let me take one problem and we calculate all these things. So let me take the problem. Okay, students, this is the problem. There are process P1, P2, P3. Their arrival times are 0, 0, 0. Their bus times are 2, 4, 8. Now this process starts in the executing. Let me draw the Gantt chart. So, okay, which algorithm you have to implement this technique means that is a longest remaining time fast LRTF algorithm once you apply this problem. This problem given in the GATE 2006, this problem asked in the question paper. So we have to calculate the average turnaround time for this problem. How to calculate the average turnaround time? AT. So TAT means turnaround time. How to calculate the average turnaround time? So let me take longest remaining time first means. So the longest process is executed fast. The longest process is executed fast means that process having burst time is more. That process is executed faster. So let me draw the Gantt chart for this problem. See, all process arrived at the 0th interval of time. So at the 0th interval of time, all process arrived for the execution mode. So at 0th interval of time, so the longest process is 8. So that is process P3. The burst time is 8. So, but it not execute to 8 times. It is longest remaining time first. So it execute 4 times only because P2 is 4. The remain next is the burst time is more. Which one? P2 process. So that's why it execute 4 units of time only. Remaining 4 units of time is left because that process starts to execute. So this is the up to 4 units of time P3 execute. Remaining 4 units of time is left to execute. So now P2, P3 got chance to execute. But longest remaining time, there is a time quantum should be the 1. Means that every process should execute 1 unit of time only. That is a time slice. Because that is a 1 is a very important factor in the longest remaining time fast. That execute 1 unit of time, then it can switch the next process. So it is a preemptive scheduling algorithm completely. LRTF is a longest remaining time fast algorithm is a preemptive scheduling algorithm. So that it execute P3 for 4 units of time, then it execute P2 will come and execute 1 unit of time. So means it is 3 units of time. It execute. It is 3 units of time is left. So P2 will execute again P3 will execute 3 units of time. So 6 is 6 units of time. Again P2 and P3 will execute 1 unit of time, 6, 7, 8. That means remaining 2 units of time is left. Now P1, P2, P3 are ready. In the 2 units of time, P1, P2, P3 are ready. So first P1 will come, then P2 will come, then P3 will come. All are execute 1 unit of time. So 9 is the P1 to complete, P2 will complete 10. So P3 will complete 11. So 1 completed. So remaining left 1 is the left remaining. So now again P1, P2, P3 executed 1 unit of time, 1 unit of time, 1 unit of time, because it is longest remaining time first scheduling algorithm. So it is 12, it is 13, it is 14. Up to 14 units of time, all process become 0, 0, 0. All are completed. So now we calculate the completed time. Now we calculate the completion time. Then we calculate the turnaround time. Then we calculate the waiting time. Then we calculate the response time, everything. So completion time. Coming to last to first to check the Gantt chart where P1 is completed. P1 is completed at 12 units of time. So it is completed at P1 completed 12 units of time. P2 completed at 13 units of time. P3 completed at 14 units of time. Now we calculate the turnaround time. Turnaround time is completion time minus arrival time. That is same 12, 13, 14. That is turnaround time. Waiting time, turnaround time minus bus time. 12 minus 2, it is 10. 13 minus 4, it is 9. 14 minus 8, 16 is the waiting time. Now calculate the response time. When P1 is arrived in the Gantt chart 8, at 8 units of time P1 is arrived. In the P1 arrival time 0, 8 minus 0, 8 is the response time for P1. When P2 is arrived, when at 4 units of time P2 is arrived. So it arrival time 0. So 4 minus 0, it is 4 is the response time for P2. When P3 is arrived at 5 minutes of time, P3 is arrived. When it is arrived actually 0, P3 arrived at 0th interval of time, 0th interval of time 0. So 0 is the response time for P3. Now we calculate the average waiting time. So 12 plus 13 plus 14 divisible by the total number of process, 3 process. So that is 7, 9, 39 by 3 is the average waiting time. That is 13 is the exact average waiting time for this problem. So we calculated everything: arrival time, burst time, completion time, turnaround time, waiting time, response time. All we calculated in this problem. Like that, every problem we should calculate similarly for all problems. So this is the longest remaining time for scheduling algorithm we solved with this example of this problem. This problem as a preemptive scheduling algorithm, every process giving 1 unit of time for the execution. That is the nature of the longest remaining time for scheduling algorithm. So we solved one problem in this example for to calculate the arrival time, burst time, waiting time, completion time, response time for this problem. Okay, then this is the job queue. So all points are coming here. When process is ready in the queue, that we calculated arrival time. Once the process submitted to CPU, then complete to execution, that we calculate the burst time. When process completed from the CPU, that we calculate the completion time. Then turnaround time is calculated completion time minus arrival time. We calculate the turnaround time. So then we calculated waiting time, that is a turnaround time minus burst time. We calculate the turnaround time. Means that the process again switch back, swapped out, and again swap in, it going to take place. That's why these two are coming to the issue: turnaround time, waiting time. So response time, once the process is arrived in the Gantt chart, when it complete, that will come in the response time. So we calculated all these process and executing in the scheduling queues. There are scheduling queues, ready queue, job queue, input output waiting queue, and partially executed swapped process that to be there in this state chart diagram, in the scheduling queue diagram. This diagram is a scheduling queue diagram. Scheduling queue diagram. Scheduling queue diagram. In this scheduling queue diagram, the process, how the process is executing, that shows in this diagram, in this figure, scheduling queue figure. So here we calculated arrival times, burst times, waiting times, turnaround times, and response time for that every process. Means that a process arrived in the ready queue, immediately we calculated that arrival time. Then we calculated burst time once submitted to CPU. Then once that process again swap out, swap in, then we calculated turnaround time, waiting time, and response time for this figure scheduling queue algorithm. All scheduling algorithms, either first come first serve, shortest job first, round robin, and then longest remaining time first, longest job first. All the algorithms are executed as per this figure scheduling queue diagram. Coming to preemptive nature. Preemptive nature that may be used when a process switch from running state to ready state, from waiting state to ready state. That's depend upon the preemptive scheduling. That CPU scheduling technique that works by dividing time slots of CPU to given a process. When burst time of the process is greater than the CPU cycle, it is placed back into the ready queue and will execute in the next chance. Burst time is the amount of CPU time the process required to complete its execution. That is a burst time. So arrival time is the process enter into the ready queue. That is the arrival time, AT. Once burst time, the process need to execute on the CPU. That is burst time, BT. When process finishes the execution, that is completion time, CT. When process spends a waiting time, that is WT. That is total time around the arrival to complete the process. That is turnaround time, TAT. Response time is the delay before the process receives its execution. That is called response time, RT. So we covered in detail of all timing factor in this video lecture. So This information gathered from Abraham Silverstraps, Peter B. Galvin, George Ganji, book titled Operating System Principles, Wiley Student Publisher, 8th edition 2010. And also the publisher, William Stallings author, the title of the book Operating System Internals Design and Principles, Pearson Education Publisher, 6th edition 2002. In detail of this lecture of time factors, arrival time, bus time, completion time, waiting time, turnaround time, and response time to clearly in this video lecture. Thank you very much. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.